So very well. So this is what I will talk about, and let me tell you a little bit about myself. So I did PhD at the Hebrew University, and I was a postdoc at Carnegie Mellon University, where we started to work on a GraphLab open source project. And after about 4 years of project, once the project became more popular, we opened a company which is based in Seattle, and we have also a small office in Israel where I'm based. So this is Dato. As I said, we are based in Seattle. We have around 50 people. We have a strong research team of around 13 PhDs. And today I'll tell you a little bit about predictive applications and how we implement them using GraphLab Create. So a bit of a motivation. One motivation slide is that we are talking about what are the cool things we can do in machine learning. And a few years ago, it was enough for a company just to have a database and store all the information in a database. But then later, not only database queries gain insight, but you have also all kinds of reporting tools. But today it's not enough to have just some kind of report. It's more interesting to have a predictive application that learns about your data, make predictions, and try to decide what will happen tomorrow. So that's the area where we focus on. We have a lot of type of applications, and I'll show you today many of them. Some examples are recommenders, fraud detection, which is cyber-related, ad targeting, and so on. So when we talk about data science, we have a kind of agreed upon pipeline, which typically you start from some data set, you take it, you ingest it, you have to clean it a little bit, make some transformation, and then you want to build a model, and eventually you would like to deploy the model for customer for making the predictions or online scoring of the model. So this is the way it's typically done, and we handle all those areas of activity. And yesterday when I looked around just outside this room, I found this nice commercial to one of the companies here, which says data scientist is the sexiest job of the 21st century, which I agree. It's a lot of fun to hear. We do a lot of sexy things, and it's very popular. And they are talking about big data and machine learning and neural-based network, whatever they are, I have no clue, and decision automation and scoring and so on. So those fit very nicely into our model of being able to capably handle the data, building models, and making some scoring on top of those models. So everything I agree here, so I would like to steal this commercial also to what we do. But if we focus a little bit about the actual modeling on its own, so we usually start with some data, then we would like to take a look of the data, explore it a little bit, and then build some models. And this is an iterative procedure because you basically, once you build the model quality may not be that great, and you may need to grab more data and then build better models and so on. So that's an iterative cycle, and on this cycle I will focus on today's talk. And I want to show you some examples about intelligent applications, what we call, that are starting and originating from data. So there are different types of data sets we are working on. Things like images, text, graphs, and tabular data, and I'll show you examples of all of them today. We also handle time series, but I won't focus on that today. So we are starting from the data, and as you recall, machine learning, data science is the sexiest job ever. So I wanted to start with some concrete examples of customer projects that we worked on. And one of the most bizarre, I would say, projects is given in this image. So anyone can guess what we see inside. So no one has a clue, I will tell you. This is a company called Compology in the US, which puts cameras inside trash bins. And in this image, the camera was mistakenly directed to the other side, so you see someone who's trying to grab something out of the trash bin. So he was accidentally captured in this image. So this is kind of the weird things that companies are really doing. So when you ask me about cameras in trash bins, it sounds a bit crazy, but it actually happens. So that's a real project. And the goal was to find, to detect how much trash there is inside in order to optimize the truck routes that go and pick up those trash bins. So that's one weird thing we've seen. The second project we were kind of involved was face detection. And this is example of some of the images we got from a company that does homeland security type of monitoring of people who enter secure facilities. And as you can see, they have a slight problem with lighting. So we got some images, but basically you can't see anything. And they said, okay, we will hire a data scientist, and he will find an algorithm to find who are those persons. But basically, as you may imagine, it's not working like that. If you have crappy inputs, nothing you can do. The most fancy neural network won't be that sufficient to understand what's going on, and that's really crappy data set. And my advice was, you should put a light in front of the camera, and it will be much better. Believe me, it will be much easier task, and you need less few data scientists. So let me show you another project. So you may say, images are difficult. We know we want to try maybe do some text analytics. Text is easy. So we got this company who told us, we have really easy task. You just have to tell us, this is a drug prescription, a real patient. I just removed all the identifying details. And here, the goal was to find the medication name, the medication dose, how many times it's given a day, and who is the patient. And as you can see, I tried to read this. I can't read anything. I don't know how a data scientist can solve this, because this doctor handwriting is horrible. So that was a difficult task we actually prefer not to take. Especially if you know text analytics, there are problems with the alignment of the page and so on. And some problems are not that easy. While the job is kind of sexy, still they are challenging items. So we talked a little about text, and usually when I give a talk, I don't like to show too many slides because it's kind of boring. So I want to show you more interactive demos of things we do, which I find way more interesting. So I would like to start with a demo I have here about Mexican restaurants in San Francisco using text reviews. So I hope you can see the font. So what we're doing here, we are trying to understand based on user reviews what they are saying and what are their sentiment about the restaurant. So typically when I say fat is a bad keyword, the food was fat, it was not good, and so on. So typically I would say, in my connotation at least, it's kind of a bad keyword. But the way we do here, it here is actually we take into account the whole context of the sentence and not just the single keyword. So what I'm doing here, I'm querying for all the Mexican restaurants that have enough reviews that mention the word fat. And as you can see, there are different scores. So some restaurants, the fat is more positive, and some of them, the fat is more negative. So I can dive into a specific restaurant, which is Tommy Restaurant. And here I can try and show you what's going on inside the review. So I don't know if you can read this text, because probably the projector is, I hope you can read it. But basically, so the first sentence I'm going to completely skip, because when you read what customers are actually generating, and everything here is real data, by the way. So the first sentence is from a crazy guy, I will skip. But the second sentence I like. So I always get the combination plates because I'm fat and I like to eat, and this is a good place. So that's a good review. And here there is a very long review, but it tells you the restaurant was kind of nice, and I gave fat tips, so I was happy. So that was a fat in a good connotation. And then another review which ends with Viva Tommy, so that's good review. And also they have a fat tequila selection, which is kind of good. From the other hand, if you are into lousy food and face value, you should go for this place. That's very negative, and we identify it nicely. And here, another one, which I like, is the room was so crowded to the point that if we want, we could have given our neighbors a fat lip or a black eye. So that's imaginative use of words. And also, the place sucks, a big fat one, and I wish I can give the big fat, and so on. So those are very negative reviews with the word of fat. So this is kind of a cool application with the text. And I want to show you a little more of the things we do also with other things. So we do handle images. So we do things like image similarities. Not this one, sorry, I want to show this one. So we do things like image similarities. So given a certain dress, I like floral dresses. The dress is sent to the predictive server, and then we identify in the store all the dresses in floral patterns. So actually, this is based on the image properties and not on the keywords which appear in the image. And as you can see, it's a very nice selection of dresses with floral patterns. So this is another application which is more in fashion. And let me show one last one quickly, which is related to, sorry, not this one, to recommenders. So this is an application where I can, it's based on Amazon data. I like a certain movie. I like Jim Carrey, stupid movies. So the query is sent to the server, and then I get all the learned movies that go together. So you know that if you like stupid movies, Jim Carrey and so on, so if you like Rocky 4, Rocky 5, and so on, they're all stupid movies, and you're kind of stupid, more or less, like me. From the other hand, whenever I want to see a movie with my wife, she is way more serious. She likes drama. She likes Jane Austen. She likes Sense and Sensibility. It's a drama movie, and we can do some graph analytics in order to find a relation between us. And then let me tell you how she convinced me to view the crap she likes. So basically, she tells me, oh, you like Dumb and Dumber, so that's with Adam Gilmore, so you should see another movie with Adam Gilmore, and then if you like it, you should see The Wedding Singer, which is with Adam Gilmore, but it's kind of romantic comedy. And if you like it, you will see Clueless, which is also romantic comedy, but it's also a parody of Emma. So many of the people that watch Clueless, they later watch Emma. So that's kind of nice. And if you like Emma, you like Sense and Sensibility, because there are two novels by Jane Austen. So this is the way to convince me. Although some people, when I say it, when I lecture, they say you're lying, your wife just telling you what to see, which is always correct. But at least I can try to have a nice story around how she convinces me. So that's another kind of application, cool things you can do with recommenders. And since we are in PyData, I want to show you actual code and how I run it, so it will be more interesting than just showing demos which are user-facing. So I'm going to show you. And about 2 months ago, I was in PyData Amsterdam, which was really nice. And there I gave the crowd, the listeners, I gave them the possibility of hearing one of two things, either web session log demo or recommender demo. And everyone wanted to have the recommender demo, so I had to give the recommender demo. Now I'm much smarter, so I'm not going to give you any options, and I'm going to show you the web session logs demo. And the reason that I'm going to show you the web session log demo is that so far you said, oh, all those crappy companies are in the US. We know everyone are crazy in the US, but I have a web session demo with a dataset from Germany. So I'm sure you will like it. And by the way, it's real data set, so I'm not going to give it to anyone, but and soon you will see why. So here I'm jumping to our programming interface, which is in Python, as I promised, and this is a IPython notebook, which is a very cool project we like. And the first thing I'm doing, I'm importing GraphLab. We are a Python-based package, and we have pip install, and we have also other types of installer. The second thing, I'm loading data with the web session information. So like in Pandas, we have a data frame, but the difference is that our data frame is way more scalable. It's called scalable data frame. That's why. And because it works from disk. So we don't load the data fully into memory, but we read it in charts from disk. So as you can see, our data has 350,000 rows. That's a very small data set. We can, of course, scale to much larger, but it's a kind of a fun toy data set to show you some quick insights using my laptop. So the first thing I'm going to do is to show you the tabular data set, like in Pandas. So we have things that like the user ID, what was the date, the time, the country. And as you see, surprise, I wasn't lying, the country is Germany. And people do decent activities at work, like going to banking portal and start games and things in this data set. Okay, so that's a real data set. I've only anonymized the IP, okay, just not to reveal anyone here. So the first thing I want to do, as you remember, we said we have some data exploration that we like to do. So we start, we do data show on our canvas, and we can see different properties of the data. So we can see the data is only in one date and so on, in a few time bins, and everyone almost is from Germany. Don't know if you can see this color, but I can convince you. So basically, it's a German data set, and we have also the ability to view it as a tabular data structure like Excel, but the main difference is that you can jump to any row and see what's inside. And we have some plotting capabilities that you can quickly plot correlations and so on and get insights what's getting on your data. So let's go back to the program. And the next thing I can do, we can do all kinds of ETL types transformation that you need in order to clean your data. So the first thing I'm doing, I would like to create a new column that will be a concatenation of the date and time columns, which are both strings. And then I would like to apply some conversion in order to get a date-time data structure. What's interesting about this call, it's like Pandas, the same syntax of apply lambda function, but the difference is that we parallelize it on all cores. So it's of that single machine, so it's more efficient. And then we have the same tabular data structure, but we have generated a new column, which is a date-time column. The next thing I can show you is that we have a lot of SQL type aggregation, like in Pandas, so you can do things like select, join, and group by. So here I want to count the unique user per country, so I can group by country and UID, and then concatenate another group by for counting the countries, and then I have for counting the unique user per country, and then I have for each country how many unique users. And as I promised, this is a German data set, so we have 6,000 users from Germany in this data set. The next thing I would like to show you is how we run analytics. We have a lot of capabilities, so one of them that I briefly mentioned is graph analytics. So it's very easy. You just create an empty graph, and then you add the edges. So when you add the edges to this graph, I'm running a graph-based algorithm on top of this graph. So I'm preparing a graph, and then I'm running connected components, which will tell me what are the areas of activities on those web sessions, whether everyone is doing the same activity, or maybe there are separate types of activities like fashion and sports and politics and so on. So I'm running it now. Strangely, it's a bit slow. That's always the risk of online demos. So let's see. Yeah, so now it's finished. So as you can see, we got some results. And the next thing we can do, we can actually count how many nodes are in each component. So that's the result of this algorithm. And here we can see there is one really large component which has 22,000 nodes. So this is a bipartite graph, by the way. So the users are connected to the website they're served in, and then we want to see whether there are different types of activities. So we can see there everyone in Germany is surfing more or less to the same website, and there are some disjoint activities on the side which are kind of small. So let me show you what we can further do in this analytics. So I'm just picking up the largest component ID, which is this number, and then I would like to join the data back into the web sessions. So why this is useful? When I have web sessions, they have certain properties, and now I'm running graph analytics, getting insights to which component this belongs to, and then I'm putting the results back into the same tabular data structure, and now I'll have another feature that will be the component ID. So in that case, I can know, and so this is a different additional column in my data set that tells me this is the type of activity this guy was doing using the graph analytics. So that's the component ID. The next thing I can do, I can dive into this component to see what's going on inside. So I can run, for example, PageRank. So it's very easy to concatenate algorithms. So I can run graph analytics, run PageRank on the largest component. So this is the pandas type selection that I'm just selecting all the rows which confirm to the last large component. Then I'm adding edges, and then I'm getting the results. So let me show you the results. As you may expected, the most popular websites in Germany are Google, YouTube, Facebook, and so on, eBay, and Amazon. So nothing surprising here. But if we look at the list or worst websites, the websites with the lowest page rank in Germany, so we have Drunken Mature Tube, Porn Sex, So Young Teens, Poker, and Manga. So those are the worst websites according to the page rank. And here we got to start to see a lot of interesting activities of what users are doing. So the next thing I can show you really briefly, and I won't go into the sex website, so I'm going to the gaming websites to spare you, but we can, it's very easy to plot those results. So let me plot it in a second. And I can show you, so those are the results, and this is people, the purple dots are the IPs, and this is the kind of games they played. And if they are, let's say, if it is data capture from work, you may say, okay, this guy is not working. I mean, this guy played one game at work, it's fine, but this guy played 10 different games at work, and probably we should fire him immediately. So that's the kind of cool analytics you can do in weblogs. So I'll jump a bit, and let me jump to the how GraphLab is built, what's the platform about. Now we have seen some applications. So we have an open source engine. So we love open source, and it's called S-Frame on GitHub, and it's BSD license, and anyone can play with it and change it as needed and so on. And on top of it, we have part of it, we have efficient data structures that allow you to run analytics very efficiently on top of the engine. So we have different types of data structure for tabular data structure, for graph type analytics, and also for time series analytics. We have also an SDK in C++ that you can, I guess this is Python conference, I shouldn't say that. But the major interface is of course in Python. And we have a lot of machine learning toolkits on top of the engine, which are Python based, as I showed you, and we have visualization. Our product does require a license, but it is free for academic usage. So anyone who is a student or participating in Kaggle competition can get a free license. Besides of our modeling capabilities, we have also a predictive server that you can serve the models. And all the examples that I've shown you are running in a predictive server that run in US Coast in Amazon, where I actually submit a query using RESTful API, and then I get quickly the response with the recommendations or the related images and so on. We also run on top of different type of infrastructure, so we have also a distributed version, but I won't get into too much details here due to lack of time. So I want to discuss a little bit about some differences to scikit-learn and some performance and why actually use us. So in terms of disk representation, we have way more compressed representation versus pandas. So because it is more compressed, we need to read less from disk. And then practically when you work in RAM, you have a speed up which is not that bad when you work from disk. So it's about 2 times slower in flash drive versus running everything in memory. And it's about 5 times slower in disk. But still we can scale as big as the disk can get. So here is the one comparison slide to scikit-learn. This is a linear regression task, and we have it. The benchmark is fully available on the web. Anyone can try it out. And here what you see is basically the runtime should be as low as possible. So the blue line is almost flat, and it's about 50 times faster than scikit-learn. But we also, scikit-learn dies at some point because it runs out of memory, and we continue running from disk. So this curve continues a long way, and you can scale to much larger data sets. Some other differences related to scikit-learn are related to the multi-core support. So all of our algorithms are fully multi-core, parallelized, and not a single-threaded. We work from disk, as I mentioned. We do a lot of automatic feature expansion, which is missing in scikit-learn. So we do a lot of things to help you get quickly to your results without creating features, translating to categoricals to binary, and so on. And a lot of work around automatic parameter selection. We do trial and error on a subset of the data set in order to give you good parameters to start with. And we have also the serving capabilities and support for many algorithms that are missing in scikit-learn, like deep learning, text algorithms, sentiment, and churn prediction, and many things that are missing. I will maybe show one more or 2 more plots regarding performance that may be relevant. So if you're using Spark, we have a connector to PySpark, so it's very easy to use our tools. And basically, we are way faster, so you'll need way more machines in Spark in order to do the same task that you can do with us without a cluster. So a lot of users, which are data scientists and statisticians, they prefer to avoid the need of actually using a cluster when you don't really have to. We are a commercial company, so we do have a lot of customers. So this is one bragging slide about the different type of use cases we see, and I've shown a few of them. And one last thing that I want to show is that we actually have a free Coursera course that you can take. It's very popular. We have around 10,000 additional students every month. And it's held jointly with the University of Washington. And Carlos Gestrin is our CEO. He's a professor at University of Washington. So anyone who wants to learn more about data science is welcome to take those courses. And I have here some brochures if you like to have the course address. And here I would like to finalize. So basically, our mission is to create sexy data science. And this is my email, and I'll be happy to talk to anyone here who is interested in brainstorming about your problems, and we would love to help.
Thank you for a very nice talk. We have 5 minutes for questions. Maybe you just have to, we don't have mics, so you just speak up, and
yeah.
Maybe you can repeat the question.
Sure, I will.
The tool looks amazing, actually. Very pleased to know it. Do you handle sparse data?
Yes. So the question was, do we handle sparse data? So we have tools to handle sparse and dense data. Our tabular data structure S-frame, you can put inside, in each column you can have a dictionary or a sparse vector. And we also support graph analytics for if you need things like sparse matrices and graphs. So yes, we do handle sparse data.
Thanks again.